G'day. Hi, I'm Adam. I'm a software engineer at zoo.dev, and I'm one of the people working on KCL, the KittyCAD language. KCL is a coding language, but unlike most coding languages, it doesn't output software. In most programming languages, it compiles into a little piece of software, and you double-click on it, and you can run it. But KCL compiles code into 3D objects. It compiles it into CAD. It's a programming language for CAD, for computer-aided design. So you can use KCL to code up mechanical engineering parts like clamps or flanges and really anything you can imagine. Anything you can do in a point-and-click CAD interface, you can do in KCL too. So today I want to demo how KCL works for you. I want to get you into your first KCL program. We're going to be using Zoo Design Studio. That's our kind of all-in-one editor integrated IDE for KCL. You don't have to use Zoo Editor. You can edit KCL and whatever programs you like. If you're coming from more of a software engineering background, you can use your favorite terminal editors or VS Code. We have a Zoo CLI that you can use to get that stuff done. But for today, I want to show you inside our IDE, inside Zoo Design Studio, because it's got a lot of really nice built-in features and integrations with KCL. The language and the API and the editor are all kind of built together, and they all work best together. So you can use them separately, but there's some pretty cool stuff you get when you use all of them together. So let's start. Let's get our first project going, and we'll take a look at what KCL code looks like. So I'm in Zoo Design Studio. I'm going to hit Create Project. I'm going to make it YouTube demo. And we're going to start. You see, it connects to the engine, then we get some basic default planes. There's 3 planes in KCL. There's, the XY, YZ, and XZ planes. So let's get started. First, just to get you started with the real simple basic stuff, we're going to talk about variables and data first. So in KCL, you can define variables. Let's call this one X. Let's call this one Y. In KCL, your variables have a name, like X, and a value, like 1. So we've declared 2 variables here. And the first thing I want to show you is that we have this variables pane over here. The variables pane shows you the value of everything. So obviously here, X is 1, Y is 2. And you can see it doesn't know what units of measurement they're using, because KCL does the units of measurement, so it just defaults them. So we can add a new one like z equals x plus y, and if you can't add 1 and 2, don't worry, KCL's got you. It shows you the answer here, 3. Obviously, this is a really simple example, but it's cool that you can check your work using KCL. You can just write the complicated equation here with all kinds of complicated engineering formulae, and you can see the results down here in the variables pane down below. So that's already one cool thing. Besides doing numbers, KCL has a couple of other data types. You can use points. Points are going to be one of the main ones we use in today's demo. So I'll show you real quick. We can have a point like x0, which is going to be at, well, let's call it origin. Origin at 0, 0. And let's make another point called P at 10, 10. Okay, so we've got 2 points there. And again, you can always take a look at them. You can see their x and y components down here. You can see that point origin has 2 elements. One's at 0, and the second one's at 0. In KCL, these points are arrays. Arrays can have any kind of length. You can have an array with lots of different numbers in it, like, all the numbers from 1 to 5. This is a little shorthand called range notation. So if you're going to put all the numbers from 1 to 5, you put 1 dot dot 5. It'll have 1, 2, 3, 4, 5 in it. But if you have an array of length 2, we treat that as a point in 2D space. If you have an array of length 3, we treat that as a point in 3D space. So we've looked at variables, we've looked at points. The last things we're going to look at are functions. You can call functions in KCL. So let's call something like, let's make our variable x. We're going to call, let's call pow. We're going to take x, and we're going to take 2, and we're going to do it to the power of 3. So you should guess that x is going to be 8. And if we open up the variables panel, we see that x is indeed 8. So this is a function call. You can see we've got the function name, which is pow, P-O-W, short for power. And then we take one argument, which is 2. And then we take a second argument. Now this second argument is a little different. You can see that it has a label here, exp, for exponent. So in KCL, every argument to a function has a label, except for sometimes the first function, the first argument. The first argument is allowed to be unlabeled. So in this case, the first argument is the base, the second is the exponent, and you have to label the second and onwards arguments. This is because it will get kind of confusing if you had code like this, pow2, 3. You can kind of guess that, it's probably doing 2 to the power of 3, but you can imagine a function with like 4 parameters. It's going to be really complicated if it doesn't have any labels in it. So we use labels in KCL quite a lot, and I think you're going to like them. They're going to be quite powerful, as you'll discover soon. So we've looked at variables. We've seen that variables have a name, and they bind to some kind of data. You can look them up in the variables panel. And you can use functions. You can send your variables into functions, and they return data, and then you can assign that data to a new variable. So we can have something like, x equals 2, and we can have x cubed equals pow x exponent equals 3. And now we have x down here, and x cubed is 8. So we've seen that functions have an input, or have several inputs, and have an output. The inputs can be other variables, and the outputs of function can be assigned to a variable. You can obviously call functions as many times as you want. We can have another function. We can have something like, let's say z is. We're going to take that pow, and we're going to square it. We're going to do x squared squared. And let's see what we get now. We get an error. Just going to refresh real quick. I think my Wi-Fi down here is not very good. So yeah, we see that z is x squared squared. So yeah, 16. We can do that again. We can take the square root of it. And we can say exponent equals 0.5. And then yeah, we get 4. Now, you probably noticed that having all these functions nested in each other like that, it's not very easy to read. I don't think it's easy to read, at least. So I prefer to use something called pipeline notation. In pipeline notation, we can write this much more easily. Instead of doing this, we can do something like this. We can say z equals, take the power of x to 2, and then we'll call another function after that. We'll call pow again, with x equals 2 again. Now, this triangle notation here, I'm going to format the code real quick so it looks nice. This triangle notation means take everything on the left of this triangle and pass it into the right of the triangle. So take everything to the left, which is x squared, and we're going to put it where that percentage sign is. So basically, we replace this percentage sign with this here. So it's doing this, basically. It's taking what was on the left of the triangle, putting it into the right, and it replaces the percentage sign. So we can then do the same thing again. We can then take the left side of the pipeline again, and we'll put it into a new pipeline. So what this is doing is it's doing take x, which is 2, and then we're going to square it, and we're going to take that, and we're going to square it again, and we're going to take that, and we're going to square root it. So we should get 4, and we can double check this. We can just have like 2 different ways to calculate it. You see that they both come out to be the same. So this way of doing the calculation and this way of doing the calculation are completely equivalent. But I find the bottom a lot easier to read, especially when you have a lot of nested functions to go through. The other way you can simplify this is that, remember how I told you that the first argument in KCL is a little special? The first argument might not need to have a label. Well, if you're going to set the first argument to percentage, you can actually just leave it out, and KCL will assume you're trying to set it to percentage. So you can see this program is the exact same. So basically, if you're setting the unlabeled first parameter to %, you can just leave it out. And that helps keep your code a little shorter, a little cleaner. You're totally welcome to put the % if you want to, that's fine, but you don't have to. I prefer to not put it in. That's just my personal preference. So okay, we've got functions, variables. You can put data into functions, you can get data out of functions, you can assign that to variables, and you can repeatedly call functions. And if you're calling a lot of functions, nesting them together, you might want to use the pipeline syntax with those triangles to neaten your code up. I think that's a really good point to stop. Let's say, stop looking at the basics. Let's actually make a design. Let's make our first triangle. So KCL lets you, or Zoo lets you edit in a couple of different ways. You can edit your models visually with a mouse by clicking on buttons. You can edit your models with AI. You can prompt an AI to give you a starting point or to help you refine and iterate on your designs, or you can use KCL. Under the hood, whether you're using buttons or AI or KCL, the whole model is always actually being stored in KCL. So you don't have to learn how to use KCL. You can basically think that all of Zoo's buttons and visual like mouse clicks and everything are actually writing KCL for you. But if you're watching this, you're probably curious about how KCL actually works, and you want to learn how KCL code can work. I think it's worth learning KCL just because it'll help you understand what your model is actually doing. So in conclusion, you don't have to learn KCL, but we're going to, in this video, just use KCL. Not going to use any of the nice buttons or nice convenient visual programming stuff we have. So stop thinking like a CAD user from traditional CAD environment where you do everything with buttons. We're going to just write KCL code for this video. In the real world, you use KCL where you want to, use the buttons clicking where you want to, use the AI where you want to. It's up to you. You can use any of those three modes depending on what task is most appropriate for it. So let's get started with some real KCL. In traditional CAD, people do a kind of sketching workflow. Basically, the way sketching in CAD works is you start off by choosing a plane, like a flat surface, to sketch on. And then you choose a point to start at, and you draw some lines on that plane. You're going to draw some lines, and they're going to join up, and where the line loops back on itself, you'll stop, and you'll make a closed 2D shape. And then you'll find some way to take a 2D shape into 3 dimensions, like maybe you pull it up into the 3rd dimension. So we're going to see how to do those things in KCL. So first we're going to choose a plane to start sketching on. I'm going to choose the XY plane. Let's get started. I'm going to start a connection to the engine, and I'm going to choose, the XY plane. So we're going to do start sketch on XY. And notice that there's this little auto predict that can help complete your code, so you don't have to type every single character yourself. So then we're going to say start profile. This is going to be where we start the sketch. We're going to start at 0, 0. Why not? It's a totally fine point to start at. Again, 0, 0 here is a point because it's in those square brackets. And we're taking the output of start sketch on, and we're piping it into start profile at. And it's replacing that percentage there. And again, we don't need this percent because it assumes that the special unlabeled first parameter will be the percent. So we can just leave it out. And then we're going to do a line. Let's just draw a line. We're going to have a line that starts at the previous point, the start profile at, and we're going to end at, let's say, 10 units along the x-axis and 5 units along the y-axis. So now if we zoom in a little bit, I'm going to move my mouse a little bit, you can see this line was drawn. And you know what, let's make it just go 4 units along the x-axis. So I changed it, and you can see it changes the visuals as well. And now from there, I want to go 3 units along the y-axis. Say 0, 3. Okay. And now I want to make this triangle. So I want to now like loop it back to the start. So I could do a couple of things here. I could say draw a line where the end is 4 units back along the x and 3 units back along the y. And that should bring us back to where we started. Yeah, nice, very good. Don't know how that got over there. But there are some other ways to write this as well. I happen to be able to calculate where this end is, but that's not going to be very practical when you have more complicated models. So I think a better way of doing that is we can use end absolute. So ends usually take a distance, right? You're saying, move 4 along this direction, move 3 along this direction. And absolute takes a specific point. So we're going to say go back to 0, 0 here. And just like before, it takes us back to 0, 0, but this one's a bit neater. This kind of captures my intention a little bit better. In fact, you can put comments in KCL to help capture your intentions. I'm going to say here, loop back to the start as a little comment. Comments don't get executed. They're really just for the humans reading the code. They're for your coworkers to read and know what you're doing, or maybe even you. If you come back to the project in 4 months' time and you remember what you were doing, you can look at your comments and figure out why. Now, going back to the start of your sketch is such a common thing that we've actually built a special helper for this. You don't have to remember where you started the sketch. You can say loop back to the profile start. Okay, so that's going to be my favorite way to end a profile. So we've now created this loop here. We can actually make it into a 2D shape. You can see right now I've got 3 separate lines. We're going to make them into a 2D shape. But firstly, just to quickly show off, when you mouse over one of these lines, you can see the appropriate line of KCL code being highlighted. Right? I click this yellow line, and it shows me that this is the line it corresponds to. I mouse over this one, I click it, it takes me to that line of KCL. So this helps make it clear. You know, if you're looking here, you're like, oh, I don't really know what that line corresponds to, that's fine. You can just click it, and it'll show you, it'll highlight the appropriate line in the visual video feed. And if you click something in the video feed, it'll show you the appropriate KCL line. This kind of two-way data flow is really important to why I think KCL is going to be easy to use than you might think. If you're not sure where a line is going, you can just click it, and it gets highlighted yellow. And if you're not sure what code a line corresponds to, you click that visual line, it shows you the line of code. Bidirectional data flow. You're going to be hearing more and more people talking about it on the street. Okay, so we've made a triangle. Now, you can see these paths loop back on themselves. That means we can close it. So I'm going to call the close function here. And you can see it closes up and it makes a 2D shape. If you try to call close on something that doesn't actually loop back on itself, like say we did something silly here, we went to 4.4, we try to call close, it'll try to make a new line that loops back to the close. So we've already got our close shape, so when we call close, it just knows it can close itself just fine. But if we left this out, it would draw a closing line back to the start anyway. So that's another option you have. So now that we've closed our shape, we've got this nice 2D shape. We can spin it around, we can inspect it, we can take a look at it. What else can we do? Well, we can turn it into a 3D shape. We can turn it into a 3D shape by extruding it. Extrude basically grabs a flat shape and lifts it up into the third dimension. And that's exactly what we see here. We've created our first 3D shape. We've created our first extruded triangle. Awesome. You can, move it around in the video feed and get whatever angle you want. If you want to get a top-down view, you can click one of these little axes down here, and you see it kind of gives you a nice bird's eye perspective on the matter. So once we have our extruded shape, you can then export it into other kinds of CAD files. You can go to the menu, press Command K if you're a Mac OS, go to Export, and you can choose a bunch of different files. And this way you can export it for importing into other CAD software, or to send it to a 3D printer and get it printed off, or to a manufacturer, to a CNC shop, whatever you want to do. But this is a pretty simple shape. I told you the kind of core CAD workflow of sketching is you choose a plane, you start drawing, and you keep adding on lines. Note that every line starts where the previous line ended. And so you keep adding these lines in, extending your shape until you eventually loop back on yourself with close. And then you can close it and you get a 2D shape, and then you can extrude it into the third dimension. And you can see that we've now got a couple of faces have been added to the shape. If you wanted to, you can then start sketching again, but on one of these faces. So we could tag one of these faces. Let's add a little tag here. We're going to say this line is tagged, side. We're going to add a new labeled argument here called tag with the tag side. And then we can start sketching on that face, on the face that's made from it. We can say start sketch on, and we're going to say, we need to make this into a variable. We're going to call this, triangle. We're going to put this whole thing into a variable. We're going to say sketch on triangle, specifically which face? It'll be that side face that we tagged. Okay, thanks for sticking with me there. Now you can see this whole face gets selected, so we know exactly which face we're looking at. And we're then going to say, okay, then start a new profile. And we're going to add, say, a circle. A circle with radius 2. And center will be at 0, 0 again. And we've now started sketching on that face. Now, I don't like the way that looks. I don't like that it's kind of going too far away from everything else. So let's make the radius smaller. And we'll move the center a little bit so that it's more centered in this face. When you put center as 0, 0, it's referring to the center of the whole scene. But we want it to actually be in this face. So we're going to have to shift it around a little bit. Let's say it's shifted up 3 this way, and let's say 2 this way. Okay, we've now put a circle there. And then that sketch already came closed because it's a circle. Obviously, a single circle can never be extended into a bigger and bigger 2D shape. So we can then extrude that. Let's say extrude it to length 3. And there you go. That's the core sketch workflow. You take a plane, you start sketching on it, you add lines to it, you close those lines off to make a 2D shape, you do something to that 2D shape to make it a 3D shape, like extruding it up, and that creates new faces and surfaces you can keep sketching on. So that's your first guide to KCL. Hope you enjoyed it. We'll be making more of these videos to show you more advanced KCL very soon. Thank you.